Okay, I think we're recording here. All right, so 27C is to apply the first derivative test to identify all extrema. So FDT. So first thing we're going to do is take the derivative, which is 1/3 x to the negative 2/3, and then we're probably going to rewrite that in this way so that it's able to be solved easier for like critical numbers and stuff. Now when we have something being raised to a power down here, it's helpful to just take whatever's underneath, oh hey, fail, that power and set that equal to 0, right? So technically I can just set x squared equal to 0. The only critical number here is the number 0, but when I make my sign chart about that, right, f prime is positive and then positive again, right? Look at this little guy here. Eyes, nose, mouth. Anyway, so since it's positive and positive, there's no extrema, right? No extrema because there is no sign change. And then likewise, if we think about what this function is, this is the snake graph, right? So this graph, oops, well, how can I actually started to draw it by accident. This graph is actually moved up 1 unit, and it is the shape of the snake. So it goes through 0, 1 right here, and it does this. So it's always increasing, right? That's what these two positives mean, and that's why this has no extrema. Oh, let's do purple for 37C. This is a mean one. So we've got a quotient to deal with. It is x squared minus 2x plus 1 all over x plus 1. So I'm going to take the derivative, like always, low d high minus high d low is 1 all over the denominator squared. Most annoying part of this is simplifying the numerator. Now, since I can FOIL the first part and I can FOIL the second part, I'm probably just going to FOIL this out. So I've got 2x squared minus 2, I think, when I FOIL here, right? Hopefully that's correct. And then minus x squared plus 2x minus 1. I'm just distributing that minus sign to all of those. So this becomes x squared plus 2x minus 3 all over x plus 1 squared. And I can keep simplifying this, right, to x minus 3 times x plus 1. Fail. Wait. Other way around. Plus 3 minus 1. Plus 3 minus 1 all over x plus 1 squared. So I'm going to take from this derivative, right, this is the final f prime, I am going to set the top equal to 0, well, whatever, and then the bottom that's being raised to a power equal to 0. So I've got negative 3, positive 1, and then negative 1 as my 3 critical numbers. So negative 3, negative 1, positive 1 into f prime. Try to do a little sign chart here. And I don't need the denominator at all in my sign chart because that's always positive. So when I test negative 10, I'm testing it into the top 2. And let's see, that's negative times negative, so this is positive. I'm going to test negative 2 in here. Positive times negative. I'm going to test 0. Best friend 0 in there, that's negative. And then 10. Positive, positive. Okay, so this is what it looks like. So now it looks like I have a sign change here and a sign change here, right? And I've got to put those back into the original to figure out the y value of my extrema. So when I plug in negative 3, I ain't going to have enough room if I do that, to f, right? I get 9 plus 6 plus 1 all over negative 2. I think that's negative 8. And if I plug in positive 1, I get 1 minus 2 plus 1 all over 2, which is 0. So if I put all of this together, I think I switched to green for this part, I have a relative negative 8 must be a maximum because it goes from plus to minus there, and at 0 it must be the minimum because the sign change goes minus to plus. So relative max of negative 8 at x equals negative 3, because f prime goes plus to minus, and then there's my stomach, relative min of 0 at x equals 1, because f prime goes minus to plus. All right. 43, I know a lot of people had questions on 43. This one was trig involved, which is never exciting to anybody. Okay, it does limit my interval to 0 to 2 pi in the direction, so that's important. So f prime is 1/2 minus sine of x equal to 0. So I'm going to add sine of x to both sides and figure out when sine of x equals 1/2. Oh, when does that happen? That happens at 60 degrees. No, 30 degrees, right? Pi sixth, and then I think 5 pi sixth. Sine is y, right? Yeah. So I'm going to put those on my sine chart, because there's nowhere else in 0 to 2 pi that sine is positive. So I'm going to cap it at 0 and at 2 pi, and I'm going to put pi sixth and 5 pi sixth. Now, I am going to do this one graphically probably, and this is what is tricky because, well, like thinking about f prime being 1/2 minus sine of x, if you think about the unit circle, right, pi sixth is here, right, and all of these values up until pi sixth, right, sine of x is less than 1/2. So if I take 1/2 minus a number that is less than 1/2, right, it ends up being positive. 1/2 minus a number that's smaller than it. So that's positive. So that's how I come up with that one. And then in this next interval, right, from pi 6 to 5 pi 6, I mean, you could actually plug in pi halves, right? So 1/2 minus sine of pi halves, which is 1, is negative. And then if we go back to this last interval here, 5 pi 6 to 2 pi, again, we're in the same situation as we were before. So this is positive again. So I have a relative maximum here and a relative minimum here. And then they just have to go into the original to figure out what the extrema were. So f of pi sixth is pi 6 over 2 plus cosine of pi sixth, and f of 5 pi sixth, I'm just going to write 5 pi twelfths plus cosine of 5 pi sixth, right? Let's see, this is pi twelfths plus, this must be root 3 over 2, and this is 5 pi twelfths plus root 3 over 2. Oh, that's probably minus, right? Because we're in the third quadrant. Oh, it's not erasing anything. Okay. Okay, like that. And then again, because of the sign changes, we know this is the relative max because f prime goes plus to minus. And then we know this guy here is the min because f prime goes other way around, minus 2 plus. Okay, let's see. The last couple, number 77. Let me kind of find that one. It says sketch the graph of an arbitrary function such that this stuff is true. So we know f prime is greater than 0 when x is less than 4. We know it's undefined when x equals 4, and it is less than 0 when x is greater than 4. So if I put information here, 4 is obviously the only point that matters on the x-axis. F prime being positive, this part tells me that f is increasing, right? And then when f prime is less than 0, right, that tells me that f is decreasing. So I have a function that is increasing to the left of 4. So it's getting higher and higher and higher. So I could do this. And then it's decreasing, right, after 4. So I could make like a parabola, but that's no good because it's supposed to be non-existent at 4, right? So what I'm going to do is I'm going to change the way that this faces. This question is probably pretty tricky here because I need a cusp, right? So increasing, I can do this up until 4, and then decreasing, after 4 gives me this cusp, right, that I need to happen in order for f prime to be undefined right there. So that cusp, right, is what allows me to draw this and not a parabola. Okay, and then lastly, let's see what's popping in number 78. These last ones always stretch our brains, right? A differentiable function f has a critical number at x equals 5. Identify the relative extrema if f prime of 4 equals negative 2.5, negative 2.5, and f prime 6 equals 3. So it has one critical number at 5. That means either the derivative doesn't exist or it equals 0. F prime of 4 is negative 2.5, and f prime of 6 equals 3. Relative extrema. What? I don't even know. Let's see. So here f prime equals 0. I don't know. So this is just saying, right, that the derivative is negative, and then the derivative switches, right, because it's positive 3 to positive. So if it goes negative to positive, that means the function's decreasing to increasing. So I think what they want in number 78 is just to say that there is a relative minimum at x equals 5. I don't think we can say what particular value it has, but we can say it has a relative minimum because f prime goes from negative to positive at that point. So I think that's what this capstone problem is after.